Hi, this is Nick N3WG. In May of 2013 this year, at the Dayton Hamvention, I was asked to give a talk on iOS rig control. I expanded that to Android, and for the folks that couldn't make it, I wanted to record it and put it up on YouTube. So that's what we're going to run through here. This was given Friday morning at 10:30 a.m. So here's what we're going to talk about, a quick overview of who I am and how we got to Pigtail, and we'll talk about how to do it yourself, some off-the-shelf options, and next steps after we have rig control. Who's this guy? So this is me, Nick. I did a lot of backpacking back in, from the early 2000s on, and I've been a ham since, I believe since 1999. So I did backpacking. I was usually bringing some sort of portable radio with me, and I had just gotten an iPhone 3G, so I wanted a logger. I wanted to make something on the iPhone that I could, log portable contacts with. So I started working on it. I've been programming for a long time, not professionally, but just for fun. So I went out and got this book, Beginning iPhone Development, Exploring the iPhone SDK, and I went through that book and did the tutorials in there, and Hamlog version 1.0 came out in March of 2009. It wasn't very good back then, but it's grown quite a bit. And then in 2010, my first son was born, so there wasn't much backpacking going on anymore, and the radio time went down a little bit, but I could still work on this app, so I kept working on it. And then in 2011, so this is 2 years after Hamlog had been out there, DXpedition went to the Caribbean and used Hamlog on the iPad to log, and when they came back I said, how'd it go? And they said, yeah, it worked, but every time we would change bands or modes we'd have to go in there and type, and it was a problem for us, so it needs to do that automatically. So I decided to see what I could do to make that happen. So let's talk about how we went from nothing to Pigtail. Quick overview of MFI. MFI is the Made for iPod program. It's a licensing program through Apple that allows you to make hardware that you can plug into an iPhone or an iPad. If you look at the bottom of an iPhone, iPhone 3 or 4, then you'll see the 30-pin connector there. So this program allows you to make stuff that can plug into that connector and actually talk to iOS. So I wanted to touch on MFI because we're going to talk about it in just a minute. So this is what I should have done when I started working on Pigtail, was draw out a diagram like this and look at what interfaces were available between iOS and Android and pick the best one. And you'll notice that two of these lines are in red. So both devices have audio, Wi-Fi, and Bluetooth. Audio, if we wanted to do some AFSK to get data in, we could do that, but that's kind of annoying and old school. We have Wi-Fi there on both devices, and we have Bluetooth on both devices, but the Bluetooth on iOS is restricted by MFI, by this program here. So if you want to do Bluetooth serial data at a high rate of speed on iOS, you have to be MFI licensed to make that product and sell it and actually have an app out there to support it. And then coming out of the phones, there's usually some sort of plug-in type connector. On iOS we have the 30-pin connector and the new Lightning connector, and then on Android we do have USB host functionality now with Android 3.2, but this wasn't available when I started working on this in 2011. Android was still sitting around version 2.2, so that was out of the picture. So like I said, I should have drawn this picture from the get-go, but I didn't. And I went out and got MFI licensed, and I started making something to plug into that 30-pin connector. This one down here on the bottom of the iPhone. So this was me on the bench just seeing what I could do. This was actually Bluetooth for Android, and this is from SparkFun. It's a little breakout board for a Bluetooth serial module. We had a level shifter here plugged into the K3. The Bluetooth module was going into this PIC. This is a PIC microcontroller, and this little box right here is actually a mechanical relay. So it was doing on and off keying at variable speeds. So it had a keyer built in. So then I started working on the 30-pin thing, and this is a development kit from Microchip for MFI licensees. So if you go out to Apple and you get licensed and you get a lawyer and you sign the NDAs and all that, then you can buy this kit, and you can plug in an iPhone directly to it. This is the 30-pin version before Lightning came out, and I actually got this working. And the further I got into the MFI process, I realized I didn't really want to do it because of all the steps you have to go through for certifications and approvals and whatnot. But I did take it to this step where we actually, designed a board, and this actually never got prototyped though. This was as far as I took it. And the other thing that I didn't like about it was it needed a cable. So these 3 pins on the left here would have been some sort of cable coming off of it. That's the transmit, receive, and ground for the serial connection coming off. And right in the middle here, this is a PIC microchip, or microcontroller, excuse me. So then I went one step further, and going back and looking at this picture here, we do have Bluetooth. Again, it's restricted on the iOS side, but I didn't like the fact that this had a wire, so I went and looked at Bluetooth. And I found this chip from Roving Networks, which has since been acquired by Microchip. This RN42 chip comes in an MFI version. If you're MFI licensed and you provide them with your information, then they'll sell you this RN42 chip that is MFI capable. So I got a development kit for that, and again got it working. And then I went down and visited Roving Networks, which is near my home. It's about 15-20 minutes away. And I sat down with the engineers there, and they said, don't do that. And one of the reasons they said don't do that is, looking back at this picture, they're the ones who made me realize that Wi-Fi was the way to go for this, because everything supports Wi-Fi, not just iOS and Android devices, but computers support it as well. A lot of things out there support Wi-Fi. So they turned me on to the RN171 chip, which is a little Wi-Fi. It runs a server, a TCP server that you open a connection to. You send data in, it goes out the serial port, and vice versa. And again, it's universal, works with iOS, Android, Windows, Mac, Linux, anything that supports Wi-Fi, this thing will work with. And one thing I didn't particularly like about it was that it was surface mount, because the original Pigtail actually sold as a kit as well as fully assembled. And I wanted to be able to kit it. And soldering that chip, I've done it maybe 5 times in my life, and it's a pain. I fried one with a bridge between 3 volts and ground, so it can be tough. It has on the bottom is a little PCB, and it has these castellated pads that you have to get hot enough to melt the solder. So then they told me about this thing. It's an RNXV, and it actually has this same RN171 chip on it. It's on the bottom. It's in between these 2 10-pin headers on either side. This allows you to do a through-hole motherboard that the RNXV would then just plug into. And it has the same footprint as XB devices. So, and actually the same pinout. So the transmit and receive serial signals are on the same pins as they would be for an XB, which is kind of an industry standard these days. So then I just needed to get some power to it. It's a 3.3 volt module, and do the serial TTL to RS-232 level shift, and then just write a bunch of code into Hamlog, and we have something working. And then in 2012 I had another baby. This is my second son here on the right, and this is that original one back in 2010. So I wasn't doing much backpacking or radio anymore, but I do still get to work on this stuff once they go to bed around 9 o'clock. So I kept going with it, and that's where we are today. We have Pigtail was released. It sold from May of 2011 until around the end of 2011 when I switched to Piglet, which is just a smaller version of Pigtail and has power poles. So if we want to do it ourselves, what do we need? We need some sort of hardware interface to get into the device. We have, as I mentioned, we have the audio, we have Wi-Fi, Bluetooth, and then plug into the bottom of the device. And it really depends on what you're connecting to if you want to do it yourself. If you're doing iOS, then You have this device down here on the bottom. This is a Red Park serial cable. You'll see it has the 30-pin connector on it and a serial port on the other side. So inside this little box here is everything needed to take that TTL UART coming out of the bottom of the phone and get it to RS-232 for whatever you're doing. They do have a software development kit for the Red Park serial cable, so you can write your own app that works with the Red Park serial cable. And you can buy the Red Park serial cable even if you're not MFI licensed. What you cannot do is publish an app in the iOS App Store that uses the Red Park serial cable because that's restricted by the MFI. If you're doing Android, Roving Networks has this little device right here with a Bluetooth chip in it that'll do Bluetooth serial port profile, SPP. They also have this RN340, which has the RN171 chip in it. It comes in a couple different antenna styles. There's a wire antenna that's just a little 1-inch piece of wire hanging out the back here, or there's an SMA connector there if you want to increase your range and get an external antenna. Or there's the Piglet, which has pretty flexible power input. This does not have flexible power input. This plug on the side, I believe, is 5 volts. And they have an actual a USB power connector, so you can run it off your computer and then plug it into the serial device. Or you can go with the Piglet. So a quick intro to app development. I'm going to talk about iOS and Android. I'm not going to talk about BlackBerry or Windows Phone. I did write Hamlog for BlackBerry and Windows Phone a while back and eventually scrapped them. They did sit in those markets for a little while, but and actually I think Hamlog is still in the Windows Phone marketplace or whatever their app store is called, but I can't update it any longer, so I don't really know what's going on with that app. So for iOS, what are you going to need? You're going to need a Mac. You can't do this on anything else. Xcode is the integrated development environment to develop Mac applications. Xcode is free. It's in the Mac App Store, and this URL here, developer.apple.com/Xcode, will get you there. An iOS simulator comes with Xcode. Objective-C is the language. It's what they call a strict superset of C, so you can actually put C code into the source code and it will compile and run. Objective-C was created in the 80s and it was licensed by Apple from this company. It's Productivity Products International is what PPI stands for, back in 1988. You're going to need a developer account, and if you want to distribute apps, I haven't checked into this for a while. I did this back in 2009, but you pay a yearly fee. I believe it's $100 for the ability to publish an application in the App Store, in the iOS App Store. And Apple gets royalties of everything you sell. I believe it's around 30% right now. Some annoyances: you need a Mac. I don't know if that's an annoyance for everyone, but you can't do this on Linux or Windows, so you have to have a Mac. And certificates: this is something that annoys me about publishing iOS applications, but might not annoy everybody. But you have to sign your applications when you submit them, and it can be a bit annoying when you switch computers and your certificate's not on that computer, or you try to submit an app and the certificate is messed up within the keychain on the Mac computer. So it's just something that's annoyed me about it, but developing apps in Xcode for iOS is relatively quick once you get the hang of Objective-C. This is the book I used, which I mentioned earlier, Beginning iPhone Development. Don't use this book. It's from 2008. There is a new version of this book out. It's called Beginning iOS 6 Development, Exploring the iOS SDK. So take a look at that book. That's what got me started. Each chapter was basically a tutorial, and it would start with building, a basic Hello World application where you click a button and maybe some text changes on a label or something like that, to more advanced concepts like tables and graphics. For Android, we have the Android Development Toolkit, I think, the ADT. It is a full-featured integrated development environment, and it's an all-in-one bundle. They didn't have this when I initially wrote Hamlog for Android back in, I think it was 2010, but I've since switched over to this, and it's very easy to use in that it's released by Google and it has everything in one download. So you unpack a zip file and there's your IDE as well as the SDKs. So it's very simple to use, and it's supported by Google. There's also you can install Eclipse and then install a plugin for Eclipse, which is the ADT plugin, which is another way to go, but I wouldn't say it's as streamlined as using the ADT bundle. Simulator comes with ADT and the ADT plugin. You'll have to download a bunch of different SDKs for whatever version of Android you're targeting. This website, developer.android.com, will get you where you need to go to download everything. The language is Java. Everything runs in a Java virtual machine on Android devices. There is also a native development kit. That's what NDK stands for. It allows you to use C compiled for ARM and executed in-app. So the app will still be Java, but the Java app will call the C code running on the underlying operating system. So and NDK is very complicated. I have one app out there. It's the PR audio app for Pig Remote that uses the NDK, because the VoIP library I'm using is written in pure C. So they offer an ability to compile that for Android using NDK and then put that into a Java application. There's a one-time fee to get started, and there's no royalties on app distribution. So if you wanted to charge for an app, you'll get 100% of the sale. Annoyances: user interface design. This is something I don't particularly care for with Android development. With iOS, everything is tightly integrated within Xcode because they control both sides of it. In Android and in Eclipse, when you define a user interface, they do have a graphical way to do it where you see a black screen and you drop a button on there. Tying that button into code is a little bit more complicated than it is with Xcode. But most of the time, because the graphical user interface for laying out a view in Eclipse or in ADT is so twitchy, most people just go over to the XML layout. So the layout that you're defining is in XML, and the graphical way to do it is translated into XML on the back end. I usually just go over to XML from the get-go and start manipulating the layout from XML because it's a little bit quicker. But again, you got to get the hang of how the XML is laid out and the format and how relative versus linear layouts work. So it can take a little bit of getting used to. The other annoyance is there's many devices out there to support. So you have phones and tablets, which are the two basic classes, but because so many vendors make Android devices, you're going to have a whole bunch of different screen sizes for both phones and tablets, and you have to, you don't have to, but supporting different screen sizes will be preferred by the users out there, because a big tablet with a phone-based interface is kind of ugly. If you want an example of that, look at Hamlog on a 10-inch tablet, Hamlog for Android on a 10-inch tablet. When you add a contact, it's just a whole bunch of fields, and they're really wide for no reason whatsoever, just because I haven't created a tablet view for Hamlog. Some further reading for Android development: developer.android.com/training has a bunch of tutorials that will walk you through, starting with Hello World and moving on to more advanced concepts, very similar to that book I referred to earlier. The reference here is the API reference for everything you need to know is in there. Alright, off-the-shelf options for rig control. So if you don't want to do it yourself, what's out there and available for you? We have LogMeIn, VNC, RDP, that's Remote Desktop Protocol, and Skype. So this is always an option. It's going to be free, but you need a computer running at home plugged into your radio. You need to interface that radio to your sound card on your computer. The computer's got to be on all the time. Audio is provided by Skype, so you need 2 Skype accounts. You basically call your home computer. There's a lot of websites out there that talk about how to set something like this up. The thing I don't particularly care for doing this is having a remote desktop on a phone. It's very small, and it can be kind of annoying to move the mouse around and click on things. So That's one of the reasons I don't particularly care for doing it this route. There's Comcat and Comcat Mobile, which was created by Howard Nurse, W6HN. He has an iOS app out there, that's the Comcat Mobile, which will talk to Comcat running at home on a computer which is plugged into your radio. And it's a very slick looking user interface on the phone. Pocket RX TX for Android. This is written by YO3GGX. There's a website there that'll get you there. It's an Android device, or I'm sorry, an Android application. Audio again is provided by Skype. Also over here with Comcat, audio is provided by Skype. This works with Ham Radio Deluxe IP server as well as the FT8X7 transceivers, so the 817, 857, and 897, and it'll do USB wired cat control or Bluetooth with a special adapter. Rumlog, it's not called Rumlog to Go. When I created this slide, this is what I thought it was called, but because it was brand new software from Tom, DL2RUM. So this is an iOS application that it's a logging application that will pull in frequency and mode for your contact. He's using Piglet, provided by Pignology. So he's written that that communication into his apps to pull in frequency and mode for your contact. And then there's My Software Hamlog, which does it's on iOS and Android, and it does cat control with Pigtail and Piglet. And Android, there's also a wired USB serial control. And today, this slide is wrong, but today on Android it's Yaesu, Elecraft, and Kenwood. I added Kenwood after Hamvention. And then in iOS it's Elecraft, Kenwood, ICOM, and Yaesu. And it's specific radios from those manufacturers. So what's next, now that we have rig control through some sort of wired or wireless interface? So the very first day I sold a Pigtail, it was at the Visalia DX convention in 2012. The very first day someone said, "Where's the audio?" And my response was, "Give me 9 months, let me see what I can do." It ended up taking a year, but what I started working on was some way to transport audio and rig control from some sort of appliance. What I didn't want was an always-on computer plugged into my radio at home. I wanted bidirectional point-to-point audio without some sort of provider in the middle, so I didn't want to use Skype, and I didn't want to use some sort of SIP proxy server on the internet. So I wanted point-to-point, true real-time audio from a phone or a tablet, as well as computers running remotely, back to this appliance. I also wanted some sort of network-based cat control, similar to what I had with Pigtail and Piglet. So I started working on it, and I made the mistake of going down the wrong path again. I had an Explorer 16 from Microchip, as well as the audio Pigtail, which is a little plug-in module which plugs into this slot right here on the Explorer 16. And I also grabbed an Ethernet Pigtail. And my plan was to get the audio streaming as well as the rig control all working in this microcontroller, which does allow you to code in C, but it's very exact in the way that when you define the or when you write the code, it's going from, you know, this line, this line, this line, this line. There's no threading there. There's I mean, you can have it jump around into various pieces of the code and do this, then go check on this thing and do that thing. And but what I really needed was an operating system. So it'd be really nice if I could do this with just some plain old C and run it on Linux, because then I have the multi-threaded, you know, multitasking operating system in the background, which can jump around and handle a whole bunch of things at one time. So I can run some sort of code that provides the Pigtail, Piglet functionality for network to serial bridging. I can run the voice SIP client or SIP user agent. I can run whatever I needed to. So I looked at single board computers. They were usually too big and too expensive, usually made for industrial type applications, and we're relying on a certain form factor with single board computers. So embedded Linux is where I wanted to go, so I looked at computer on modules and systems on module devices, which provide a CPU and a bunch of peripherals and then a header. So on the other side of this Amadeus APF28 module are two, I think they're 96-pin headers, which break out all the peripherals, which would require quite a bit of engineering, because all the passive components to make those peripherals work, like the audio, would need to be designed and worked out. So then I looked at off-the-shelf development platforms like the Raspberry Pi. The Raspberry Pi is cheap. The cons I have listed here is no audio in. Serial would need to be added. There is serial on that header right there, if I'm not mistaken. I need to add that in. The connectors are laid out awkwardly, so getting this thing into an enclosure would be difficult, and I would have unused connectors on the outside of the enclosure, which I didn't want. Also, the CPU is closed. You can only get the documentation for the CPU under NDA, so I didn't particularly care for that. So I looked at the BeagleBoard XM. It does have audio in and out on board, as you can see in the picture here. It has serial. This particular serial port is for the shell, basically the console of the Linux system. There's another serial port on one of these headers back here, so I'd have to break that out. And again, the connector layout was awkward. I didn't want connectors on the outside of the appliance that are unused, so I didn't go with this one either. And then I found the BeagleBone. The BeagleBone is very similar to the BeagleBoard, except it has minimal connectors on it. So we have Ethernet and power back here, and we have a USB host connector here. There's a SD card here, which is actually the operating system for the device. And also, what you can't see in the picture, there's a USB connector on the other side of the board on top that has a that's the shell, the Linux terminal. So if you wanted to log into it and actually get to a command prompt. It doesn't have built-in audio though, but it can be made. It does have a channel there. It's the MC ASP channel, where we can bring some audio in to the operating system. So we need to make a motherboard to break out the serial and the audio. There's a bunch of UARTs on these pins too. There's 5 of them. So I can use one of those for the Pigtail functionality, and then I make a little audio daughter card, and I can connect that to the operating system. So that's what I did. This might be kind of hard to see, but this big green board is that motherboard, which basically just does the connecting of everything. And then the audio codec is this small board here. It's about 1.5 inches square, and it has this is a 1.8 volt voltage regulator here. There's an oscillator, and then this is the actual codec, which is a Texas Instruments audio codec, and then the other passive components to bring it down to the headphone jacks right here, which are 2 stereo 3.5mm headphone jacks. This is a excuse me. One of those UARTs is broken out here, which is TTY01 or UART2 of the BeagleBone, which is just has traces coming into the UART here. This is the level shifter chip here. I also put an XB footprint on here, which we'll talk about in a little bit. And actually, in this picture, this is a BeagleBone Black. I was doing some testing after the Black was released, and eventually chose not to switch to it yet because of some changes they made to the kernel. But I might change to that at some point. So now we have rig control and audio. We can do full remote, rig control. We can press a button on our phone, and this is all built into Hamlog. So we can press a button on our phone to put the radio into transmit. We can talk to our phone and stream that audio back over to. Oh, by the way, this ended up becoming a product called Pig Remote. There's a website at pignology.net which has a bunch of information on Pig Remote. So now that we can do streaming audio and rig control, what's next? And the question is, I can operate my rig remotely, but what about turning the radio on and off, or flipping a coax relay, or measuring the temperature, the PA in the radio, things like that. How are we going to solve that problem? And this is a really good job for a microcontroller. So a PIC, again, microchip PIC, amazing little devices. And I know a guy, George Zafiropoulos, is KJ6VU from Sierra Radio Systems. So I'll jump into what he did at Hamvention. I actually handed this off to him, and he presented a couple slides. What he created was something called a station controller. So using this interface right here, this XB, we have a wireless link. An XB is a digital data radio that can create a mesh network. So there's one in Pig Remote, and then there's one in the station controller from Sierra Radio Systems. And then I wrote software on the BeagleBone which will take in a network stream, send it to the XB, which sends it wirelessly over to the station controller, and then the microcontroller in the station controller acts upon it. So I can send a state request and pull on the state of all the various relays that are on there, or I can actually flip a relay on or off. It also measures voltages and current through a main, a large relay that's on board. So you send the power from your power supply into the station controller, and then out of that it connects to your radio. So you can actually flip the power to the radio on or off, all going through the station controller. And that large relay that's in there, there's two options. There's an 8 amp relay and a 30 amp relay, or 20 amp relay, one of the two, to turn on, you know, could be a bus power connection to all your various components in the shack. He also has an AC relay if that's required, so you could use one of the smaller relays to turn on the AC relay, which turns on your power supply, and then you can turn on the DC relay to turn on power to your entire station. And that's all measured and monitored through the PIC, and it's polled every few seconds and displayed on the screen. So that was the end of the talk. I don't have anything here for getting in touch with me, but I can go ahead and write it on the screen here. Come back down to the end here. So support at pignology.net will get you to me. Again, I'm in 3WG. The website where all these products are, the Pignology specific products, is http://pignology.net. So information on piglets there, as well as Pig Remote. And that's it. So if you have any questions, feel free to send me an email, or you can leave a comment here on YouTube and I'll respond to it. And let me know what you think. Thank you.